Hello, this is Joshua Michael Himes, and this is my ME2900 Arduino project. Here's my face so you can see it. This project, the basic premise is that this is a temperature monitoring device for inside a computer case, which the Cheerio box symbolizes or shows. What we have going on here is we have that two sensors inside, both temperature sensors, but one measures temperature and humidity. Measure those, and the Arduino displays it to an LCD screen that the user can see in order to tell what temperature is going on inside. The problem that this is meant to solve is when using overclocking. One of the biggest problems is that the CPU or some part that you're overclocking overheats, and that can damage the component. And so using this, you can tell what the temperature is. Another thing it does is if the temperature gets too high, it will alarm you and tell you, oh, it's getting too high, by making this buzzer go off and lighting up the LED. Another feature is that this potentiometer can adjust the brightness, and this button starts the program and can change between Fahrenheit and Celsius. So let's see if this works. There's the temperature, there's the humidity. Press the button. Look at that. This is in Fahrenheit right now. You can usually just tell because of how high the number is. And this is humidity in percent. So let's press this again. See if it changes to Celsius. Voila, it does. Change it back. Yep. When it refreshes, it changes back. And then we use this potentiometer. Can change the brightness to where I like it right there. Okay, another part that we have on here, a fan. It spins and it turns on too when the temperature gets too high, along with the buzzer and LED in order to cool down the computer. Okay, the two sensors we have inside are the TMP36. It's right on this wall over here on the inside. And what it does is it measures the temperature in analog in bytes from 0 to 1023. And then that is converted from voltage to Celsius and Fahrenheit if wanted. Then over here on this wall we have the DHT22 temperature and humidity sensor. The humidity is put right here, directly displayed. And the temperatures between the two sensors are averaged because it was found that different sensors can have different readings, like 2 to 3 degrees off. So averaging them, I thought, gives a more accurate reading. Okay. And now, in order to see the alarm working properly, we have our program right here. The reason I don't put my fingers on the sensors to try and change the temperature is that once you mess with the sensor and make it hotter than it is, it takes a while for it to cool down. And so it can make if I mess up on the video and have to do it again, it makes it take a while. So let's see, the temperature right now, about 70 degrees, so let's put this to 65. 65 degrees, that's the alarm temperature. Change it to 65 degrees Fahrenheit. Let's upload. There we go. Okay, upload done. Come over here. We have to press the button again to start it, so we're going to do that. So this is over 65 degrees, therefore the LED is lighting up. I don't know if you can hear the buzzer over the fan, but the buzzer is going off. Here, let me put my finger on the fan to stop it. Do you hear it? And that's the buzzer. Over here, the fan's only making sound because it's hitting the side of the box. It is spinning right now. Let me stop it for you again there. See? Spinning, cool down the case. And if I were to cool this down, which I can't, but if I could, the alarm would turn off. Let me turn this back to, let's say, 80 degrees. 80 degrees is the base temperature because most CPUs have, the manufacturer says 80 degrees is about the top of what someone should have it. So I uploaded it. Press the button again. Voila, the alarm does not go off right now. And now, let's see, let me just upload it again so I can show you the serial monitor. There's also a serial monitor with this that was used in debugging. I left it in the code so you know what that is. It can also be used to display the temperature in Celsius directly to the screen. Over here, press the button. There. And also this shows how the temperatures in the two sensors are different. This right here is the TMP sensor. This is the DHT22 sensor. And notice that the temperatures they average around are different. Also notice the DHT is a little bit more accurate. That's expected if you looked at the data sheets. This is more accurate than the TMP. But since the bases are different, I averaged them because they might be precise, right? We didn't know if they were accurate or if they need calibrated. So I come over here. I'm just going to show you the inside. I'm going to open this up. Here. Okay, there. Bumped it a little. Here is the DHT22 sensor. Here is the TMP sensor. There's the fan. There's two breadboards in here because I like to be modular. This controls this stuff. This controls the fan. As you can see, I tried to color code things, but I ran out of wires. Everything that's yellow is the LCD. The 9-volt battery powers the fan because there wasn't enough current from the Arduino. So we have a transistor right there controlling that, and an LED was used as a diode, but that's all it is. It's just a diode that lights up. Okay, so I come over here. Still working. Notice this. I'll have this right here. Look at that. I'm going to put my finger on this right here, as I think I might have said before. I don't usually do it like this because, see, if you put your finger directly on one of them, it heats up really quickly. And then notice how the temperature is, it was normally at 60 degrees, it's a little above it now. So it'll stay like that for a little bit. And that can make it hard when trying to redo videos. Over here, I'll put my finger back on it. Notice the TMP, that's what I have my finger on right now, lights up. Goes up pretty high because this is Celsius. So that's pretty high, it's going up. You heard the alarm go off for a second because it got too high. I took my finger off. Over here I put my finger on the DHT22 right now. Notice it went up a little. It doesn't heat up as fast because there's a plastic casing around it, so I can't put my finger directly on it. Over here, you see it's not really going up, it's bouncing back and forth because the TMP36 is cooling right now because I only have so many fingers while the DHT22 is heating up. But if I put my finger over on the TMP36, because it heats up quicker, the alarm will start eventually. There you go. Yep. Going up higher. 96. 76. 77. Yep. There we go. Just see it jumps up because I'm really heating up one, but I'm not heating up the other, so any outliers start to play a big role as it's averaged between. But okay, that's the project. We can close it back up. It's a little hard to do with only a couple hands, but close it back up. Normally it's taped more, but I wanted to be able to open it up to. It's easier to see everything. But yeah, that's the project. Thank you for watching this. I hope it's polished enough for you. I didn't use an actual computer case because I didn't want to have to drill holes in it. And if I were messing with my actual computer, I'd want to be a little bit more careful with things and put it in more permanently with glue and stuff. And if I messed up, it'd be hard to mess with that down here on campus. But okay, thank you. This is Joshua Heim. Show my face again. Thank you for watching this. This is my Arduino project.